In this lesson, we're going to be talking about some special vector types known as sequences and repetitions. The first function I want to talk about is the sequence function, and this function takes 3 arguments. Let's learn a little bit more about the sequence function. So it generates a sequence, and there are a lot of ways to use this, but I'm going to show you the simplest way we can use it. If we use the tab completion on the sequence function, it will show you the different arguments. The 3 main ones that you need are from, to, and by. What this means is if I enter the numbers 1, 10, and 0.5, is that it's going to give you the range of numbers from 1 to 10, incrementing each step by 0.5. So if you enter that, it's going to return 1, 1.5, 2, 2.5, and so on until it hits the number 10. Now, if I were to enter 1 instead of 0.5, it returns the same thing as if I do 1:10. Here's another example. I'm going to do each iteration by 0.01, and you can see that it returns around 900 different values. If I did 0 instead, it would return 1,000. We can also add a variable as the by argument. So if I want to see the values of 1 through 10, and for by, we'll set it to equal pi. Then it's going to give you 1. It's going to add 3.14 to be 4.14, and so on until it reaches 10. If we pass in a single number, let's say the number 5, it's just going to return the vector of integers from 1 through 5. When I'm writing a function like this, I'm sort of doing it shorthand. Really, what we're saying is we want the argument from to equal 1, the argument to equal 10, and the argument by to equal 0.5, like our original example. When I don't assign this value to the argument and just enter 1, 10, and 0.5, it's assuming that it's in the right order. It assumes that the 1 is going to be from, the 10 is going to be to, and the 0.5 is by. If we mixed up these arguments, it would give us an error or might not work the way we expect it to. So the reason that first one didn't work is because it's trying to go from 1 to 0.5 by a positive 10. So that doesn't really work. You can go from a higher number to a lower number, but then your by argument has to be negative. So let me show you a better example of that. Let's say we want to go from 0 to negative 10 by 0.5. It won't work, but if I do negative 0.5, then it works just fine. So let's compare the integers 1 through 5 with a sequence of 5 and see if they equal the same thing. And what it returns is a vector that is the same length as the vectors you're inspecting, and it will return a true or a false for each one. Sequence 5 is 1, 2, 3, 4, 5, which is the same as 1 through 5. So when I ask it this logical question, are they equal to each other? What it's doing is that it's comparing this first object in the sequence to the first object in the range and asking if they're true. So for each one of those cases, it's true, and that's why it returns 5 trues. If you want to know if the vectors are just equal to each other, instead of knowing if each object in the vectors are equal to each other, we can use the all function. So if I enter this logical argument into the all function, it's asking, are all of the values true? This all function is basically saying, are all these Booleans that were returned true? And they are, so you get true. And if you put an exclamation point in front of the all, it's going to return false because it's asking the opposite of that. The other function I want to introduce to you is the repetition function. If I use the repetition function, I'm going to enter in 2 arguments, 1 and 5. What this is doing is it's going to repeat this value this number of times. Now, I can also repeat a vector as many times as I want. So let's say I want to repeat the vector of values 1, 2, and 3 5 times. You'll see that it goes 1, 2, 3, 1, 2, 3, 1, 2, 3. We can also repeat character strings or Boolean objects. Here, it returns a vector, which is that string that I want to repeat, and it repeats it 100 times. Or you can repeat Boolean objects. These are pretty helpful ways to create vectors of numbers. The sequence is very useful, and it's very similar to using the colon notation, and both of those we're going to be using a lot.